All right, start kits. When an electric motor first starts up, you have an inrush of current. So the electrons are flowing through this motor extremely fast, and they're running at the full speed. So whatever speed of the windings that motor is supposed to be at, they're running at that full speed. But the motor has lag. It's not immediately up to speed yet. It's like getting in your car and immediately flooring it. It's not going to be up to 60 just yet. It's a lot of wear and tear in that car getting it to speed fast. So the windings, you have an inrush of current. As electrons are flowing through there, it's a very high amperage rating. And those windings get very hot. And what is on the windings of that motor?
Enamel.
Insulation, enamel. Yep, it's an enamel that's on there. As that windings get very, very hot, that enamel starts to bake and burn off. And every time that motor starts up, there's a big inrush, so it has damaged that motor every single time it starts up. Plus, there's a big power draw when it starts up. Plus, as all the electrons are rushing to get this motor started, you'll have a voltage drop in the rest of the house. The voltage it takes voltage everywhere else, and it has a bit of a drop. So your lights, sometimes your AC starts up, your lights will dim, which can be hard on your electronics, like your TVs, things like that. You have a voltage drop on there. It's a big, big problem. Plus, your capacitor has a lot of electrons flowing to that, well, not flowing through, but your capacitor has a big surge going through it as well, so it's getting very hot also. We know that heat kills a capacitor. When does a light bulb fail?
When it gets too hot.
When have you in your life have you noticed a light bulb to fail?
When it cracks.
Filament separates.
Yes.
When it burns out.
Yes. When is that? Absolutely. When you first flip it on, that instant little poof of light, and that's it.
Yeah.
They're never on, and then all of a sudden they just fizzle out. It's always when you first turn them on. You had a question?
When you clean them when it wet right.
Oh, well, I've never done it. That's a temperature change. Expansion, contraction, that'll do it. You shouldn't use a wet rag when it's on because of electrocution also, though. You had a question?
What if the light's always on and it goes out?
Very rarely does it happen, though. Usually, most of the time when a light bulb goes bad, it's when you first click on it. You go to the closet, click, little flash of light, and it's like, oh, man.
They're always changing lights in the casino, though.
That might be an outlier. Because the casino
That's a
lights
whole
are
other,
on.
all the time. Those will, but I imagine those last longer staying on than versus coming on and off, 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 on and off.
Well, and some of them flash constantly.
That's true. Well, actually, all of them flashing. These are flashing.
Oh, that's true.
Yeah.
But when it's cool, that first inrush of current comes on, that's when they pop. So a capacitor is the very same way. When you get that inrush of current, all the electrons moving back and forth across, the electromagnetic is happening, they get hot. That's when the capacitor most likely pops, when it first turns on. So if we could add a kit to this motor to help it start. What's the hardest part about pushing a car? Getting it started, right? Getting that push going. So if I could add a component to get this compressor up to speed faster, which means the windings stay cooler, which means there's less inrush going through or having to deal with this capacitor. The capacitor is going to last longer, the compressor is going to last longer, and because it's getting up to speed faster, the lights don't dim down like they did. The compressor is going to last many years longer, capacitors last longer, and some people say even the contactor lasts longer because there's less pitting going on every time it comes on and off. If I have one part that's going to make all those components last longer and possibly save you a little bit of money as when it starts up, not that you're going to see it on your electric bill much, but it would save you money every time that compressor starts up. Is that something you're interested in?
Yes.
Absolutely. So it's called a start kit. They are usually mandated if you have a thermostatic expansion valve metering device, a TXV or TEV metering device. They want you to have a start kit on them. Also, if you have hot climates. Can't think of anywhere we have a start climate. Also, if you have systems that cycle on and off. Any one of those. You need a start kit.
So everyone has a start kit. They should have.
Should, here in Vegas, everyone should have a start kit. Now, let's say that we live in Maine. Is there going to be as hot of conditions in Maine?
No.
No. Is your unit going to have a high demand on it? No. So it's not going to be as important there. But in Maine, you may need an accessory called snow feet. You put these feet on the bottom of the unit and it raises up about a foot or so. That keeps it above the snow line so that snow doesn't build up all around the unit and rust it out faster. That's some accessory you'd probably need to have in Maine, more so than a TXV. Now here in Las Vegas, do we want snow feeder in the units here?
No.
No. If we have that much snow here, we have way bigger problems than the AC, right? Okay. We have big problems. So what they do is they build the units, a base model unit, and then you customize it for what you need. Most units have regular fixed orifice in it. You like a TXV, you buy the kit. You like a TXV, you buy a kit. You guys don't like TXVs, it comes without it, it's cheaper. So the same thing with start kits, they don't have start kits with them from the factory. We all know in Vegas, start kit's going to be better. So you can add the start kit to it. It's pre-assembled, you just got to plug the wires in the correct spot, and it helps that unit last longer. Every unit here needs one. I go to every customer I have and they have a bad capacitor. I'm already putting the capacitor in. Hey, I got a brochure I leave them about the start kit. They don't have one. I explain the benefits of it, explain what it does, and then ask them, is that something that you'd like to have? And they'll say, well, how much is it? And I'll say a price, and I say, and we accept credit cards. And they say, yes, put it in.
Price, we accept credit cards.
We accept Bitcoin.
How much do they cost?
Our cost for a start kit, which includes a start capacitor, and it includes a potential relay. A potential relay, also known as a start relay. Also called a pot relay for potential, not for anything else. I know this is Vegas. It includes that and usually the little wiring setups you need in it. Our cost is about $50. Not bad at all.
You sell them for
$250 or $300, and I'm already there making money on something else. I'm already making money on a capacitor. So when I put this in, I don't have to make as much money on this. But there's companies that put those in for $500, $600 easy every day. There's one company I know that sells those for $800. Still worth it. Still worth it. These things are so awesome. You can have a compressor that won't start at all. Your compressor can be bad, won't even start. Turn it on, the outdoor fan motor comes on, the compressor goes, ding, shuts off. Won't even start. I can put this on your house and get that compressor running a lot of times, not always, a lot of times, and I can get another maybe 2-3 years out of that compressor that would not start by putting this kit on there. If it can extend the life of a compressor that's already dead, imagine what it can do to a compressor extending the life of while it's new.
what's the picture?
Picture? This? Oh, I didn't draw a picture of it. Well, who cares about a picture? Let's see the component. I'm a visual aid guy. All right, a start capacitor. It's they're usually black. They have a plastic, so it doesn't have to be mounted metal to metal to metal. You can cable tie it somewhere in there. All right, just wrap the cable tie around it. And this has a little foot on it, and there's a little space for a screw. In the unit somewhere, there's an extra free screw usually there, already there. You can unscrew that screw, and that screw is there because they know that most places are going to need a start kit. And you can put that screw in right there, and you have 3 wires right here. 3 wires to hook up. On this relay, it has numbers 5, 2, 1, and then there's wires on it. So on the wires, it's called 5, 2, 1, common, start, run to the capacitor. 5, 2, 1, common, start, run. 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 I'm going to look in this relay, and number 5 terminal is black. What do you think that's going to go to? Common with the rest of the commons from that compressor. There's 2 black wires in the contactor. Guess where this is going to go? With those, that's right. 5, 2, 1, common, start, run. It's hooked to the number 5 terminal. Number 5 is common. Then the number 2 terminal. Number 2 terminal is start. Well, where's the start winding? And this helps the compressor. So where's the start winding for the compressor? Here, but I can't put it there. Where else can I put it?
Put it right there.
Oh, right there. They give us extra spots. I put this one right there. And then the last one says run to the capacitor. It's also red. What color is red usually? Run. And it goes to the capacitor, to the number 1 terminal. So the same leg that powers the running powers the capacitor. I put it right there. So one goes here, one goes there, and then common goes over here. That's it. That's how they wire. Really complicated stuff. They even have a diagram on the thing. When we open it up, though, we see a little relay on there and a switch. Switch is normally closed. So if we were going to wire it in, it would wire something like this. That's how the wiring looks. You don't have to draw that right now. I'll have one I'm going to send you. What happens is this capacitor and this capacitor are wired in parallel, which means we just simply increase the plate size of both capacitors. So this one here is 227 microfarads. That's between 189 to 227 big microfarads, big capacitor. Plus whatever capacitor my actual run capacitor is. So we have a big charge when it first gets up and first get that compressor going. Heavy hitting microfarads. Gives that big boost through the start winding. Gives that big boost, that big surge to get it going. Once I get that compressor up to about 75% speed, this start winding also, 1/60th of a second, becomes a generator. So it's creating higher voltage, right? Now that means the potential difference across both sides, I actually have potential difference, which means there will be higher voltage. That higher voltage goes to this very high resistant coil, electromagnetic coil. Once I get it to 75% speed, I have enough pressure to make amps flow through that coil to create an electromagnet. That electromagnet then opens this switch. Once that switch opens, it takes this out of circuit. This is only used to start the compressor, and then it pulls it out of circuit so that it's not there anymore, only to help it start. If you try to wire this in all the time, it will do one of two things. Either A, those big surge will burn out the start winding, or it will blow up this capacitor. Okay? So I pass it around, and you can take the cover off and see the coil in there. And I have one that's blown up. The morning class did not burn this up. They're good guys. Most of the time.
No, the guys at API.
I can say though that the entire class does fit in the electrical room over there where we put the
Often. Yeah, no, they're good guys. They're good class.
They got several companies, or that's just something that we think?
These, there's several people that make them. This one is called the 521 Compressor Saver. That's the brand, is 521 Compressor Saver. They have 3 sizes. So it's like a 1 to 3 ton, a 3.5 to 4 ton, and a 4 to 5 ton or something. I can't remember the numbers exactly. But you get one size for that unit. All right, so it's a start capacitor and a potential relay. They have different sizes. Here's one that's still in the package. I'll pass it around the other way. Don't open it. I still may need to sell this one day. I have my sign that says, "We'll HVAC for food."
Hey man, someone might pick you up, and it might be someone in the Tesla like, I like that. Yeah, that's the first thing I ever seen.
Those are the ones that's 3 wires. So if I have it hooked up, there's 3 wires. The black one goes common. The red one goes to run, which is this side of the capacitor, and the other one goes to start, which is the other side of the capacitor. Right? It's not hard to do, and there's pictures on the back of that tells you exactly where the wires go. It's really not hard, right? So there's people out there who go, "Oh, I can't wire these." Really? Now, one thing I want you to know is 521 common start run. 521 common start run. So common start run. So when you go to an interview, you may have somebody ask you a question of, "How do you wire a start kit?" And you're going to say 521 common start run. And if they'll ask you to wire, draw it out. Okay, 5 goes to common. It's going to be black with the rest of the commons. 2 is going to go to the 2 terminal is going to go to my start winding on the output of the capacitor. And number 1 is going to run into the capacitor to the number 1 terminal of that relay. Boom. And you've explained how to wire it. And they're like, okay, good. And they'll move on. Okay? Yes. Don't ask them those. Ask questions, but not those kind of questions. Don't challenge them because they're going to challenge you back. It's not going to be kind of like don't challenge me in class. I challenge you back. Yes, sir. No.
What is that?
It's a transformer that varies, and they also have variac capacitors that vary, and we don't use them very much. So we're going to just. I don't have the time to get into that, anyways. So 521 come and start run. They also make other types. There was a company that had problems because their technicians couldn't wire those. And some people, you may go to a company and they're like, hey, I want you to wire one of these from scratch. You really don't need to because they come pre-wired. Okay, so I can spend all the time teaching you how to wire them all through, but really, if you can do this, 521 come and start run, you're going to get the gist of it down. They have wiring diagrams on there. If you have one in the truck, you need to wire one, just pull the package out of the truck. It tells you how to wire it right there. I don't want to spend all that time when there's more important stuff to learn.
How come the fan doesn't have one?
Because the fan is very small and there's not much against it. It just has a blade to turn. And as the fan gets up to full speed, then there's more air weight against it. But the compressor has to turn a piston and connecting rods and valves, and it has a whole lot of work to do and a weight to move before it gets up to space. So it's the bigger motor. It needs that help. The fan motor, there's very little resistance when it first starts, and as it gets up to speed, there's more resistance. Doesn't need that. This big guy needs it.
Sort of like one's like trying to ride a bike, the other's trying to start a car.
Actually, like trying to push somebody riding a bike, trying to push somebody driving an 18-wheeler.
You
don't want to, just really drive that home. So there's another guy that said, oh, that's too complicated getting my guys to wire those 3 wires. There's people in the field that, oh, I don't like those 3 wires. They're too complicated to wire. Really? 521, come and start run. The blacks go together, only leaves you 2. And then it tells you 2 goes to start. And then it tells you the color. The yellow one's going to...
That's when you tell me. It's literally not hard. I would rather have to test about this 8 million times.
So, but they made one that was simpler. All right? They made this one that's 2 wires. You take a blue wire and you put it on one side of the capacitor for the compressor. You take the other blue wire and put it on the other side of the capacitor for the compressor.
So they made it harder?
So in case you guys missed that, here's my compressor one, and I take a blue wire. Does it matter? The other blue wire.
Doesn't matter.
Here we go, opposite side.
So it does.
Do they have a simpler one?
Oh, you would be surprised.
It doesn't look like a can.
We had a guy that worked for a company in Texas, and he went out installing these, and he hooked them between C and fan. So he's sitting 225 microfarads. So it's a little bitty cute fan motor. So we had to go back and replace all the fan motors because it burned the start windings out of all of them. Oh,
Did the
yeah.
factory smoke come out of those fans?
So it's a 2-wire. This is a brand called Kickstart, but it still has a potential relay and an actual capacitor built in. And there's other sizes. Here's the bigger size one that somebody pulled one of the wires out. All right, so it's a larger one, but on the package it says the size of units they work with. Still, it's 2 separate components, but it's still 2 wires, blue and blue. One side of the capacitor and the other. I prefer the other ones just because I can wire them. You get people that are on teams, I like this one better and that one better, but if somebody says I like this one better only because it's 2 wires, I'm like, really?
That's what you're
5, 2, 1, come and start, run.
The AC. That's what you're worried about is because there's 3 and not 2. Come on, dude. That's crazy.
Another brand that I like really well is called the Amrad.
Did you get half of that one? Yeah, I did. This is like, I'll tell them when I say, alright, what's this? What? You got pens?
I don't have pins. This one has, they come with markers though. You can put the date on it.
Hey!
That way, you should probably use those because that way you actually get a date. So this one actually has the relay built into this capacitor. It's all sealed. So it makes it nice and simple. Plus, it does all the different sizes. And there's another style like this that does them as well. So it does all the different sizes for your start kits. So if I was going to put one in, I'd use the 521 Compressor Saver brand, the Kickstart brand that's 2-wire, or the Amrad brand that has many different options. Those are the ones I would put in. Now, in the field, you're going to hear some people say they don't like putting start kits in because they damage compressors. These will not damage compressors. Once it gets up to speed, it takes the start winding out of circuit. There are other ones that will damage the compressor. Okay? So let's talk about those. They're cheaper. So those are like $50, but they can sell these for like, I don't know, $15. People are like, whoa, $15?
What's the catch?
So here's this one's a Supco brand called Super Boost, and this one is I forgot Super. I think this is Super Boost also.
Super.
Anyways, what they use in here is not a pot relay. They do not use a potential relay. They actually use what they call a positive temperature coefficient, a PTC. And all there is in here, if you open it up, there's two different plates in here. And they use temperature. So when the electrons are flowing through this so fast, that plate gets hot, and as the plate gets hot, that's what disconnects it. Solely off of temperature. So on a cooler day, or the right conditions, this could stay in circuit and send too many microfarads to the start winding for too long, which could damage the start winding. These can damage the start winding. Also, if this is already warm and the compressor is running and then shut off and then tried to start again, since it's already warm, it doesn't close back to help the compressor start. So the compressor is trying to start and it can't because it's off of a PTC temperature coefficient. I call it a POS start kit. Right? These are the ones that will burn out. So if you hear somebody saying, oh, those start kits will burn units out, I'm telling you that these are the ones that will burn units out. Right? I have these that are used because I pull them off of units and put in the right one because these are junk and will damage the customer's equipment. So just because these are bad doesn't mean all start kits are bad. Right? Don't go stereotyping them. These particular ones are bad. Those particular ones, there's 3 other brands that work really, really well. These are junk, those are good. These wear it out, those extend the life.
You would never install those whole things.
Hell no. Now they make one like this for refrigerators. Refrigerators work completely different. They actually work decent for some refrigerators to buy time, but it's replacing parts. It's a long story. For HVAC components, do not use these. These are crapola.
You call it a positive temperature coefficient?
PTC, positive temperature coefficient. Yes, sir.
What's the 3 brands?
The what?
The 3 brands do you like?
Oh, 3 brands. 521 Compressor Saver. 521 Compressor Saver is the one. The other one is a brand called Kickstart. Kickstart is the other one I like. Kickstart, and last, but not least is the Turbo 200. I don't get paid to sponsor Turbo 200. It's a good product. I like it. I believe in it.
I don't get paid by Jameson, but it's a good product. I like it.
Yeah, exactly. Exact same.
I think.
You get the same quality every time.
So,
Yes, sir.
I noticed Kickstart had a 4 on it. What is that?
Say what?
The Kickstart had a 4 on it?
A 4 on it.
Like,
Where? Where's it at? Show me what for. I don't know this 4 you speak of.
I think that's it. Okay.
All right. Let's see. Do-do-do-do.
Weird.
Yeah, I had a question about that one.
There's a light.
4. Oh, there's no terminal there. They make other ones that have different points, like a 4s and different numbers. We're not worried about those. Some applications they make that you'll need those. Very rarely, and if you do, there'll be a wiring schematic for that, for a reason for that.
So, this piece on here,
Ah, good. What is that?
Is that a resistor?
Let's see what this point is you're talking about.
Yeah, the little colorful tube thing.
Is that a resistor?
Hello.
I mean, why is it there?
Hey. All right.
How
So
you doing?
that is the resistor. It's called a bleed resistor. Where'd the wires go? All right.
Yeah.
It's a bleed resistor. So those hold a massive amount of microfarads. It'll store a lot. There's a lot of plate size in there. So it can be dangerous. So what they want is a bleed resistor so that over time it bleeds it from one side back to the other. It's not as quick as those that I gave you guys, but it keeps it from holding a massive charge over a long period of time, so it's not as dangerous.
So that'll eventually equalize itself then?
Yes, it will.
Okay.
Slowly will allow it to equalize. And you can actually count the colors of the bands and calculate what the resistance is of those.
So this says 4 to 5 tons. So
Yes.
does that mean you can only use it on a 4 to 5 ton?
Yes, that's correct.
Okay.
I do not want to use that for a 3.5 ton or a 3 ton or a 2.5 ton or a 2 ton or a 1.5 ton or a 1 ton or a half ton.
If it's not 4 or 5.
Then you go. So in other words, there's like three, actually really two different sizes that fit just about everything. So I'd go stock several of those, and I stock my truck several of those. I want to have enough to where I don't have to go back to the supply house. I want to go to the supply house maybe once per day, restock everything I need, and go do all those service calls. Because if you go, you need this part, you go to the supply house, you wait in line, you get all this stuff, you eat some donuts, and you go back to the call, and then you do another call, you need another part, you kill a lot of time. Plus you gain weight from all the donuts. I'm serious. It's a real problem. It's a real thing. Some of the things you need to be concerned about. Some companies, though, have a guy diagnosing units. So you diagnose a unit. And then they have this guy go and replace the parts. He's a parts changer. And they'll have another guy that he goes and he runs parts. So this guy says, here's what I need. And then a dispatcher will send that guy to go get the parts. They'll send you to the job. By the time you get to the job, he's getting there with the parts, and it works very efficient. They do have some companies that do that. Yep. Right, so what is this? What do we use it for?
Capacitor, metal.
Metal, upright when possible. All right, what's the difference between a run capacitor? What's a run capacitor look like?
The run capacitor.
It's usually metal. What's a dual run capacitor?
It's a big one that's 2.
Two capacitors in one, right? What's a start capacitor look like? That's plastic, much higher microfarads, only for starting, temporary use only. And then what's the difference between a start capacitor and a start kit? Yep. Now,
I was going to ask this question, but is this where the start kit is? This right here?
yep,
Yeah.
that's the start kit. And I'll draw them better for you guys. But this essentially is the start kit. And the start kit, you guys are going to hear some older school people.
I asked the wrong question. I meant the potential relay.
Oh, that's the
This
potential
part.
relay is this part. Yep.
Okay.
Got it. It relay is. This is your relay. And we can label this 5. Common start. This would be 2, 1.
521.
5, 2, 1.
Common start run.
You're going to hear some people that call the start kit, they call them a hard start. And it took me a long time to get me away from it because everybody I knew called them a hard start. But really a hard start is not the proper name. Because a hard start implies that it's only when the compressor is having a hard time starting, right? I mean, hard start just sounds, well, wait, you're going to put a hard start on my unit? Is there a problem with my units? But you're having a hard time. All these questions, oh my gosh, what's going on? Oh my God, blah, blah, blah. Right? No. A start kit. It helps the unit start. It's a much better word. When you say hard start kit, although there's so many old school guys like me that grew up with that word, it's really the improper word. It's taken me a long time to get away from that word. So that's why I do want you guys to know when somebody says a hard start, but try to use the proper word, a start kit. Because when you start talking to your customer, it's going to be an advantage for you to use the proper word. Okay? Any questions? None? Yes, sir.
The cheap ones, how is it that they burn them out?
Because they're junk. They're just built bad.
So,
They don't work. They work
Oh,
differently.
so instead of it taking it completely out of circuit, it waits till it gets hot enough. Like the other one, it uses back EMF, back electromagnetic force, to create an electromagnetic coil to disconnect it. So the other one just uses temperature. There's a piece of biometal in there. And when the biometal gets hot enough because the amps are flowing through it, the biometal goes clink and opens the circuit up. So you're only on temperature. your temperature different and when the unit's running or not running, you're either going to burn out your start winding by sending too many microfarads for too long, or you're going to burn out your start winding by the unit not having any help starting when it needs it the most. So it'll burn out the start winding.
Would you call that open loop automatic control?
Yes.
Good, I got it.
I wouldn't call it that, but yes, you could.
And what's the difference between a start kit and a start capacitor?
A start capacitor is part of a start kit. It's just a capacitor. A start kit is the capacitor and the required potential relay to make it work. And the relay is built into that big one. The relay is in the bottom. It relay is. I really do.
You could probably throw that into like words in your tongue. That
Any other questions? Tomorrow we're going to hook one up in the unit so you guys can see how it installs.
Yeah.
And till then, study because we have a test tomorrow that we're supposed to have today. And tomorrow we talk about contactors, the second most replaced part. And fan motors, the third most replaced part. What's wrong?
Oh no.
You good?
Yeah. I took pictures.
Good. Oh, we should touch this off.